In this video, we will be testing the mine endpoint that we just created and the receive new block endpoint that we just created. So to get started, you should have all 5 of our nodes running, and at this point you should have connected them all together to create a blockchain network. So over here in the browser, we can see that we have 5 nodes running and they are all connected together. Cool. So what we want to do now is we want to test our mine endpoint that we just built out. Basically what our mine endpoint will do is it will mine a new block and create a new block for us. It will also take that block and broadcast it across the entire blockchain network so that every node is synchronized and they all have the same blocks and the same data. So that's what we hope to see when we start mining some new blocks here on our blockchain. So let's get to it and see if it works. So let's open a new tab, and the first thing we have to do is choose a node to mine our block. So we have 5 nodes we can choose from, and for now let's just stick with the first node. So we will go to localhost 3001/mine, which is our first node. And let's hit this endpoint. Cool. So it looks like our mine endpoint worked. It says new block mined and broadcast successfully, and it shows us what the new block looks like right here. So let's head over to our first node, which is the node that mined this new block, and let's refresh it. Cool. So we have a second block inside of our chain, which is good. This is the block that we just mined. And we can tell that it's the block we just mined because the hash is the same on this block as it is on the block we got back from our mine endpoint. You can see that it ends in 12100. And over here on our first node, the hash ends in 12100 as well. Cool. So our block was mined successfully on our first node. And you might have also noticed that down here we now have a pending transaction. So why do we have this pending transaction if we haven't created any transactions yet? Well, this pending transaction is actually the mining reward for this block that we just mined. And since we updated our mine endpoints, our mining transaction is broadcast after the new block is created. So from now on in our blockchain, when a new block is created, the mining reward for that block will go into the pending transactions and it will be added to the next block. And this is actually how mining rewards work in the Bitcoin blockchain. The mining reward is added to the next block. So that's just something that I wanted to clarify in case you were wondering why this appeared right here. When we first created our blockchain in the first 2 sections, we put the mining reward right into the block that mined it, just to simplify things when we got started. But now that our blockchain is more advanced and we have a decentralized network, it's important for us to follow best practices and put the mining reward into the next block. Cool. So back to our mining endpoint, which is what we're testing in this video. So we can see that our new block was mined successfully on our first node, and the mining reward was generated successfully. Now's the moment of truth. Now we want to go to the other nodes inside of our network and make sure that they got the block that was generated, as well as the mining reward that was generated. We want to make sure that our new block was broadcast and the mining reward was broadcast to the entire network. So let's see if the other nodes have this data right now. So we'll go to node 2 and refresh this. Cool. It looks like our node on 3002 received the newly mined block. And we can tell it's the right block because the hash ends in 12100. This node also received the mining reward transaction, so we know that that was broadcast successfully as well. Great. Everything's looking good so far. Let's check our third node now. And let's refresh it. Cool. We have our second block that was just mined, and it's the correct block. And we also have the mining reward transaction. Awesome. So it looks like our blocks and our transactions are being broadcast correctly to our whole network. Let's keep checking to make sure. So on the fourth node, we'll refresh this. And we have the second block right here. That's good. And our mining reward transaction right here. Perfect. And finally, on our fifth node, let's refresh this. And we have our newly mined block right here, as well as our mining reward transaction right here. Perfect. So it looks like our new block was mined and broadcast successfully. Very cool. Now, if we want to mine another block, we can use any node to mine a new block, and it should be broadcast to the entire network. So let's do that now. Let's mine another block from a different node. So instead of going on 3001 this time, let's go on 3004. And let's mine a new block. Cool. So our new block was mined, and it says that it's the third block. Perfect. And the hash for this block ends in 7DA1. So we can check to make sure that all the nodes have the correct block. So let's do that now. On our first node, let's refresh this to see if it received the block that was just mined and broadcasted. Cool. So we have our third block right here. And the hash ends in 7DA1, so it's the correct block. That's good. And also, inside of this block's transactions, we have the mining reward from the previous block. So this transaction right here is the mining reward that was generated from when our node on 3001 mined the previous block right here. We also have a new mining reward in our pending transactions, and this mining reward was generated when our third block was mined. Perfect. Let's keep checking the other nodes to see if they received the correct data. Cool. So our node on 3002 has the third block, and it's the correct block. That's good. And it also has a new mining reward transaction. Perfect. Let's check our third node now. Cool. Our third node has the third mined block and the new mining reward transaction. Let's check the fourth node. The fourth node looks good, has the third block and the mining reward transaction. And the fifth node. And the fifth node looks good as well. Perfect. So it looks like our mine endpoint is working just as it should. It's creating new blocks and broadcasting them to the entire network. So the entire network is synchronized and has the same exact blockchain data, which is really important for a blockchain to work properly. This is pretty awesome how this is working. Cool. Now let's test a little bit more. So what we want to do now is we want to head over to Postman and let's create a couple of transactions and broadcast them. And then let's mine a new block to see if our new transactions are added to the blockchain correctly. So in order to broadcast a transaction, we want to hit the transaction broadcast endpoint, and we want to send in some example transaction data. So right now I'm going to send in the transaction data of 100 Bitcoin. And we can send this transaction to any node that we want to, and it should be broadcast to the entire network. So let's send this transaction to our node on 3002. Cool. It looks like our transaction was created and broadcast successfully. Let's make a couple more transactions before mining another block. So let's make a transaction worth 200 Bitcoin, and let's send it to our 5th node this time. Cool. It looks like that worked correctly. And let's make one more transaction that's worth 300 Bitcoin, and let's send it to our node on 3002 this time. Cool. So let's head back over and let's check our nodes real quick to make sure that they all have the pending transactions that we just created. So let's refresh node 1. And it looks pretty good. It has all 3 of the transactions we just created, plus the mining reward from the previous block inside of our pending transactions. Perfect. Let's check our node on 3002. And 3002 looks good as well. It has all 4 transactions that we expect to see in here. Node 3. Node 3 looks good. Let's check node 4. Node 4 looks good. And let's check our node on 3005. And this one looks good as well. Cool. So we can tell that all of our transactions are being broadcast to the entire network correctly, which is pretty awesome. Now what we want to do is mine a new block to make sure that all of these pending transactions are added to the new block correctly. So let's do that now. So first thing we have to do is choose a node to mine our new block. So this time, why don't we choose node 3003 this time, and let's mine it. Cool. So it looks like our new block was mined and broadcast successfully, and it should be the 4th block in our chain. And from our response, it looks like we have the correct transactions inside of it. But let's go to all of our nodes and check to make sure that's correct. So on localhost 3001, let's refresh this. And right here we have our 4th block, and it has all of the transactions in it that we expect to have in it. Cool. And then if we check our pending transactions, those have been cleared out, and the new mining reward is present in here. And it's the only transaction in here, which is good. Cool. So it looks like our new block was mined and broadcast successfully. At least it was broadcast to our first node successfully. Let's check the other nodes. And refresh this. Cool. So our 4th block is here. And we have all 4 of our transactions right here. And we have our new mining reward transaction inside our pending transactions. Perfect. On our 3rd node, let's refresh this. And our 4th block that was just mined is right here. And it has all 4 of our newly created transactions inside of it. That's good. And it has the 1 mining reward transaction pending. Perfect. On localhost 3004, let's refresh this node. And this is the node that mined the block. And it looks like everything is pretty good here. We have our 4th block right here with all of the correct transactions in it. And 1 pending transaction, which is the mining reward. Cool. And finally, our node on localhost 3005. Let's refresh this. And we have the 4th block right here. That's good. It has all of the transactions in it, and we have one mining reward transaction pending. Perfect. So this is pretty awesome. Basically, what just happened is we created a couple of new transactions on different nodes, and those transactions were broadcast to the whole network successfully. Then we mined a new block, and all of the transactions we created were added to that new block successfully. So that's pretty cool. On top of that, our newly mined block was broadcast to all of the nodes inside of our blockchain network. So all of the nodes across our entire network are now synchronized, and they all have the same blockchain data, which is pretty cool. If you really think about what is taking place right now, it's pretty impressive. We have a decentralized blockchain network that's currently running across 5 nodes. We also have built out the functionality to synchronize the entire network, so all of the nodes inside of our network have the same exact data. This is pretty awesome, and it mirrors how a real blockchain would function in real life, which is pretty cool. We've got something pretty powerful running for us right now. Cool. So at this point, we have a pretty cool decentralized blockchain network running, in which all of the data is hosted and synchronized across the 5 nodes inside of our network. So in this section of the course, we successfully synchronized our entire blockchain network. At this point, I would encourage you to take some time and test the mine endpoint that we just created and mess around with it, and mess around with the transaction broadcast endpoint, and mine some new blocks, use different nodes to mine different blocks, create new transactions, and really just get a feel for how this whole blockchain is working. The more you test it, the better understanding you'll have of how everything is working under the hood. Well, that wraps it up for this section of the course. In the next section of the course, we will be building out a consensus algorithm to make sure that all of the nodes inside of our network can agree upon what is the correct data to have inside of our blockchain. And it's going to be pretty cool and a pretty powerful algorithm. So I'll see you in the next section.